Hello, everybody, and welcome to How the Web Works, featuring your host, Kyle Coberly. By the end of this lesson, I sure hope that each and every one of you will be able to distinguish between the web and the internet. And I hope that you will be able to describe the HTTP request response cycle. If we can do that by 12 o'clock, I'll feel pretty good. All right, so first objective, distinguishing between the web and the internet. They're not the same thing. They're not even close. So let's see, I want to start off a little active here. So I'm going to say, I want you to spend 4 minutes. Let's do 4 minutes. I want you to write me your best distinction between the web and the internet. You can look stuff up, whatever you can do in 4 minutes. That'll give us a good place to start. All right, 4 minutes. DM me on Slack the distinction between the web and the internet. Go. Feel free to use Wikipedia, the internet, anything you need to help you out. 4 minutes.
Hey Kyle, did you say to DM you on Slack or right here?
On Slack, please.
Okay.
Let's take another minute. Great answer so far. All right, if you have not sent me a message, please do so. In the meantime, David Henderson, I liked your answer. Would you read that out loud, please?
Yeah, of course. So the internet is a collective network of computers, whereas the web is the pages that are loaded. I went to the bbc.co.uk website, and they had a cool analogy, and it was that the internet is the roads that connect the towns, and the web is the stores and homes in the towns.
Very nice. Excellent. So a lot of people picked up on the internet being infrastructure and the web being content. There are some finer distinctions between those, though. So I asked a couple of you for examples of web technologies versus internet technologies. And there is some kind of crossover area that I want to talk about a little bit. So let's dive in. So when we talk about the internet, we are just talking about computers talking to each other. What they're talking about, that's not really part of the internet. Just the fact that they're connected. So you end up with a network where you have all these little nodes on it, and all of them can talk to each other. Cool. What's the technology that we use to know how this computer talks to this computer versus this computer? How are they addressed?
With routers.
It's part of it.
Your IP.
Yeah, there we go. So each of these has an IP address. So IP addresses, there's two different kinds of them. I'm going to show you the old one because it's easier to understand. Numbers between 0 and 255, and there's 4 sets of it. So you might have 213.0.55.127. So that might be the address of this computer. And then this one could have a totally different address. Just because they're next to each other doesn't mean that the numbers are necessarily close. Okay, so each one of these computers on the network has an address. So if I want to send a message, I go, hey, can you send this message over to the computer at this address? So this is part of it. This is just a network, though. It's not an internet. The internet part of it is it's a network of networks. So at each one of these addresses, we can have more networks behind that. So for example, I'll show you my home network. So if I look at the things that are on my network right now, this is everything that's logged in. These are their IP addresses. You can't send messages to any of these IP addresses though, because they're in my house. This is my network. This is the green part here. I also have an IP address that like Comcast gave me. So if I go like, what's my IP? Cool. That's this number right here. So you could send messages to my house, and then my router gets to go, cool, what do I want to do with these? Where do I want to send this? Should I send this to another computer on this network? That's the internet. Again, what's being sent in these messages? Immaterial to this. But this idea that all these things have little addresses, and behind those addresses, fractals all the way down. That's our internet idea. And there's some pretty fucking cool visualizations. IP map. Let's see, not that, not that. This is the one I'm looking for. This is the internet. And if you scroll all the way in on that, each one of those is an IP address. Looks like that. Pretty cool. So that's how all these computers and phones and devices and stuff talk to each other. All right, cool. Ask me some questions about this idea.
Within the green, is that still considered the internet, but like a sub level of it, or is there a different name?
That's just a network. This is just a network too. The concept that we have networks of networks of networks, that's the internet.
Okay.
That I can send. So if I have another one of these over here, that's kind of behind this one. If this computer can get to this computer, it does so over the internet. Within it, you just say it's networking.
Do networks within closer proximity to other networks work faster, or is it all the same?
Yes, they do. Like at some point, this is just physics. It's faster to send a message over wires to somewhere in your own city than it is to somewhere in Singapore. And to that point, like when you have servers on AWS, Amazon's like a big giant box of servers, you specify the city that you want the server to be in, because presumably you want it to be closer to wherever your users are. And you might have mirrors of those that are in different places so that somebody's always talking to a computer that's physically closer to them. Because yeah, like at some point, like the speed of light comes into play with how quickly these messages can come across. Pretty wild.
How does the cloud come to play in effect in all this?
Sure. So the cloud is just somebody else's computer. So I'll give you a good example. So my computer, like the computer that I'm on right now on my home network, so that's behind my my router in my house. I can also log into it remotely by looking up whatever my house's IP address is that like gets assigned by my ISP. That's part of my router. I can look up what that is, and if I send a login request on a specific port, and I wave my hands the right way and enter the magic incantation, it'll let me log into that computer from anywhere else on the internet. That's pretty cool. But I'm still logging into a specific computer. The cloud idea is that we hand wave around all of that. And we go, I'm going to give you something that's kind of like a computer, but you don't actually know where the computer is. It might not even actually be a physical computer. It might be a logical computer. So like it's just code that makes it look like it's a separate computer. That's how all of like Amazon Web Services, Google Cloud, all of those things are like fake computers that they let you log into. But the fact that you don't know if they're real or fake, you don't know where they are, you don't know any of the underlying infrastructure, that's what makes it the cloud.
So in sense, if it's not a physical or like a figurative server, why would, because isn't like the whole point of like cloud is faster data response and transfer? Or is it just like data storage is like somewhere in the cloud and then like you're just it's like putting a database somewhere in the cloud and just letting it sit there?
No, it's not faster, it's more abstracted. There's a whole set of problems that you don't have to worry about if it's not important whether or not you know whether or not it's a physical computer. That's the benefit of the cloud. And like things like AWS and stuff, it's once upon a time, like not that long ago, like 10 years ago, if you had a company that was like serving up websites, or you have a web app or something like that, you would order physical computers from CDW, and then like nerds would sit on the floor with screwdrivers and like put in the hard drives and rack them up. And then they'd like that when you made a request to Yahoo or something, it was going to Yahoo headquarters and their servers, or they'd have those physical servers in like a secured area, like probably somewhere in the same city. And so that's how all that worked. The thing is, these are commodities. There's nothing, there's no artisanal, like handcrafted servers. It's like electricity. And so this cloud idea is like, cool, what if we put an abstraction in front of all of this and then just like say, hey, how much computer would you like? And offer you sort of fake access to that over the internet.
It's like
And
how you can go to Kohl's and buy like a pound of jeans.
Yes, exactly. And so now instead of like having to know how many servers to buy, and then like when the hard drives break, I gotta fix it. That's all Amazon's problem now. One time, this is beginning of my career, I had to request a web server from Pearson, and I had to fill out a lot of paperwork. I had to have 3 meetings about it, and it took 6 weeks to get my servers. That's, I don't know, 15 seconds now, maybe less. That's game changing. And if I want to start a company, then cool, I can just use some cloud resources and just pay for what I'm using. I don't even need to know how to set this stuff up. Hard drive fails on one of those things. Cool, not my problem. I have a contract with Amazon for them to worry about that. That's the cloud. Other questions about the web versus the internet?
So just for like the idea of the internet, my brain thinks like intramural, like sports or whatever. So it's just when you have multiple nets and they've got like some connection between the two of them.
Yes. Okay. An interconnected network of networks.
So a quick question, this might be really stupid, but like, so VPN networks, you're not physically changing your IP, you're masking your ID basically, right? So your physical server location wouldn't change no matter what. It's just masking your IP address with another one.
Like when you watch Netflix in Mexico or something?
Exactly.
Okay. So yeah, you're using somebody else's IP address that is in Mexico, and you're routing all of your traffic through them. And so you end up with some lag because like, all right, well, I have to connect to Mexico, and Mexico makes the actual like request to Netflix, and Netflix is streaming the video back to them, and then they pass it back over to me. So it's a little slower because we're making an extra hop in there. But now Netflix doesn't know that I was the one that wanted to watch the video. All it can see is that the request came from the server in Mexico. That's how those kinds of VPNs work.
If you're using like that kind of service, then isn't there like a huge security flaw then? Because you're basically like mimicking their IP and like using their IP address. So don't you have like kind of like access to it all?
No, like more that they can see everything that you're sending through it. That's the security risk.
Mind blown.
How can I tell if somebody's using my IP for their VPN?
Oh, like they wouldn't. These are services that people use. So you're like, I am offering up my IP address. If you want to send traffic to me, I'll forward that on and then send you back the results. And you'll notice any of those VPN services, they're always like security, privacy. We don't store anything. That's why, is because they're in the middle of all this traffic. So technically they could see anything. But yeah, you pay $5 a month or whatever, and they'll route all your traffic through them. So it could be because you want to be anonymous. It could be because you want to watch, because the rest of the world has way better Netflix than we do. What else?
I know it sounds weird, but I mean, when you do a VPN, it's almost like you're laundering cash, right?
Yes. Correct.
How is this still legal? Like, if you're gonna torrent something and you turn on your VPN, no one's gonna know that you're torrenting whatever.
Correct.
So, I guess my question is, how is it still legal?
Sure. Who would stop it is the better question. Like the internet isn't owned by anyone. It's just like different parts of the infrastructure are owned by different people, very few of them governments. But like if we look at internet backbone map. So this is the infrastructure, what we call the backbone in the United States. So like these are physical cables that are going from city to city. So when we're talking about this network of networks idea, you have your home network, and then you have one that's in your neighborhood, and you have one that's in your city, and you have one that's kind of in your rough geographic area. Highest level one is the backbone. And these backbones are like generally owned by different companies that maintain and upgrade them and whatever else. Now, like the more interesting question is why do they all allow each other's traffic? Because like they don't have to do that. And funny story, like there was actually like an issue at one point where one backbone owner got mad at another backbone owner and stopped accepting their traffic. And so the internet just went down. And that was like in Chicago versus Western half of the United States. And so something like, weird, if I'm asking for a website where the server is in Chicago, I can't see it all of a sudden. Or like more sneaky, if they're using a resource that's hosted on a server in Chicago. So like the internet just broke for a little bit and then they kissed and made up and then it worked. But like, that's what we're talking about here. This isn't regulated by anyone. It's actually part of the power of it. Because so the internet, this is an old idea. This goes back to the 60s or so. As a Department of Defense project. It was part of the government. And, 40 years go by, 30 years go by. And they're like, well, you know what? Some nerds at universities like tried to share research and stuff using this network, but I don't know. I think we've gone probably about as far as we can with it. All right, cool. Open it up to commercial traffic. And that was like 1988, 89 or so. And so the internet as we know it happened immediately after that. But yeah, it's entirely decentralized. Even if like, and there have been a lot of people that want to make a lot of things on the internet illegal. How? How would you do that? It's decentralized. So the way that you would make that illegal is what China did. So the Great Firewall of China, all traffic going in or out of the country goes through government servers. So it's kind of like the VPN for Netflix thing, except like the bad way. Other questions about web versus internet?
And so if that's what if the internet is sort of like all like the connections allowing the computers to talk with one another, the web is just the conversations.
Correct. And like there are some specific technologies behind this also. So like there are physical cables and there are protocols those cables use to send each other messages over the internet. And so there's actually an entire stack of those. And if you end up going into networking, you will learn all about the OSI model, which are the different stack of technologies that kind of make the internet work. Everything that we do in this program is this top level, application level. All the rest of this is internet. Cool. One more question on web versus internet. What you got? Cool. So let's talk about HTTP. So yeah, around the 60s or so, we start building out this network. It gets used by universities. It really isn't going so far. And like, all right, well, you know what? We'll just kind of open it up to the public. So there's a researcher at CERN named Sir Timothy Berners-Lee. I guess he wasn't a sir at the time, but Timothy Berners-Lee. No one invented the internet, like no one person invented the internet, Timothy Berners-Lee invented the web. So this was, I want to say like 92. Let's check it out. Timothy Berners-Lee. Let's see, this was 89. So in 89, he's a researcher at CERN, and he goes, I wonder if we could use the internet. So he's a researcher, wants to share his research with other researchers. I wonder if we could do something like hyperlink documents. So when one paper is referencing another paper, like you could just click on like a hyperlink, and it would take you to that paper. So that's the birth of the web. And so a couple technologies kind of come along with this. One is URLs. These are IP addresses, but like we look up Google's IP address. I would like just look at this actual network request here. And say, all right, there you go. Google.com equals this. So I can also just type that in. Put that, if you put that in your browser, hey, look, it takes you over to Google. This sucks ass to remember though. So we come up with these short names. Call them URLs. It's like a phone book. Just translates between the URL and the IP address. The URL is a lot easier to remember. And so nowadays we also have all kinds of different things that, so like the actual phone book that stores which URL goes with which IP address, that's called DNS. Who's allowed to have which names? There's an organization called ICANN, the Internet Corporation for Assigning Names and Numbers, that goes, all right, well, you bought this domain. And then even within those, they're like kind of the government of that. And then there's a bunch of smaller companies that handle things like .com. So like .com is administered by a company called VeriSign. So when you buy a .com, even if you bought it from name.com or GoDaddy or something, like that ultimately went through VeriSign. They're just brokers for that. Cool. So that whole system, URLs, that's part of the web. Another part of this, browsers. All of this like internet stuff for years and years and years, just command line. And there's a lot you can do with that. You go, all right, I'm going to send this request to this computer, command line, command line, command line. The idea that you would visualize any of this stuff, that's a new thing. Tim Berners-Lee writes the first browser. The underlying technologies that the browser is like consuming starts with HTML. I'm going to mark up my research documents with HTML and hyperlink them together. So when you click on something, it takes you to that page instead. A few years later, wouldn't it be nice if the pages could look different? So that's birth of CSS. And then a really fascinating part of web history, I'd recommend looking up sometime, is the history of scripting languages for browsers. So around 1995, it's like, we can actually do quite a bit more than just mark up research papers here. I wonder if we could do some programming with these kinds of things. And so there were a whole bunch of different efforts to come up with a scripting language for browsers. And there were like probably 3 or 4 pretty viable ones. And but they were exclusive. Like Microsoft had one for Internet Explorer, and Mozilla had one for the Mozilla browser, and Netscape had what there was. Yeah, it was Netscape then. Netscape had their own one, and there's all these competing different browser scripting languages, and they all kind of beat each other up, and it's network effects. if a site only works on one browser, that kind of doesn't work. And so they sort of all mutually died out, except for the one that everybody thought the least of, which was Netscape's, which was called JavaScript, because Java was like just come out, super popular at the time, and they wanted to capitalize on the branding for Java. So they called it JavaScript, and it sucked. And so nobody thought it was a threat, and so they kind of ignored it. And now it's the only language that runs in browsers as a result. Weird. So all that stack kind of comes along with browsers, URLs, browsers, HTML, CSS, and JavaScript. And then we need like a format that we can send requests for these files. And then we need a format to interpret these. When we get these files back, how does it actually turn into like graphics and stuff that show up on a page? So that's HTTP, Hypertext Transfer Protocol. How can I get these HTML files back and forth? HTTP. This is the web. That was a whole lot of stuff. Ask me some questions about it.
Yeah, I just have a quick question. Why is everything on the internet hyper? Like, why is it hypertext and?
Sure. So hypertext is kind of an old idea. The idea that like you could click on a word in a document and it would take you to another document, that's called hypertext. I don't know why they didn't ask me. I think that's like an 80s thing. But the origin of it was like within like your file system. And so if like if you're an old timer like me, you might have used a program called HyperCard. That was an Apple product in the early 90s, where it's kind of like PowerPoints or something like that, except you can click on things and they take you to other slides. That idea is called hypertext. And since that was the original intention with the web, hypertext markup language, hypertext transfer protocol, like even the CSS and JavaScript weren't part of like the original vision for any of this. It was just sending linked documents around, and hypertext is what we call linked document.
Awesome, thanks.
I have a question.
Mm-hmm.
So I know the difference kind of between HTTP and HTTPS.
Yep.
HTTPS is secured, but like, how is it secured?
Sure. So question is, what makes HTTPS secure? All right, so I'm on this computer. I send an HTTP request over to this computer. So there's no magic to it. It's just text. So like, see if I can actually get the raw request. Cool. So like that's what an HTTP response looks like. It's mostly HTML. Oops. Oh man, I can't get the. Oh, here we go. Like these are the headers for an HTTP request. It's just raw text. It's formatted a particular way. That's the protocol part of it. But it's just text. Cool. So my very sensitive thing with my username and my password and my credit card number, that goes out in an HTTP request, which my router can see. So if like I'm on my company's network, they can just watch those things go out of their network. And then it doesn't go straight here. It goes through my ISP, who can now also see all of those things. It goes to this person's ISP, who can also see all of those things, goes to their router. They can see everything that I sent over, and then to that person. Womp, womp. That sucks. So what HTTPS does is before I actually send the content, me and the person that I'm sending this to, it's called a three-way handshake. We agree on an encryption scheme. It's like, cool, I'm going to encrypt everything that I send to you, and I'm going to encrypt it this way. And this person goes, yes, I see, I understand. And then that's the thing that gets sent across the network. And so only me and my recipient can figure out what the actual message was. That's HTTPS. And it happens in a fraction of a second. It's so fucking cool.
Cool, thank you.
Other questions about the web?
So at what level does like JSON and XML and all that stuff come in there?
So this would be, so this is a transfer protocol. These are just like an agreed format for sending messages. This would be a level below this. So within those messages, we might format something as XML, as JSON, as HTML. So these are all formats that could go inside of this message. So this is what's in the envelope. This is, you think of HTTP as the, that format that we use for addresses on envelopes, where you have the name of the person, and then below that you have the street number and the street name. And then below that you have the city, comma, the state, and then the zip code. So we say that's a protocol. HTTP is just that for the internet. And then within those messages, we can format this data however we want. But like these different data formats, they all do effectively the same thing. But yeah, if I want to move data rather than pages, XML and JSON are the two most popular formats. And honestly, XML is all but dead at this point. It's pretty much just JSON. HTTP ain't the only protocol in town either. Anybody ever heard of POP or POP3? Or its closely related cousin, SMTP? Or their closely related cousin, IMAP?
Is SMTP secure media transfer protocol?
Ooh, good guess. Where have we
Simple
seen
message.
these words? You've probably stumbled across them before.
It's mail.
Yep, exactly. These are the protocols used to send email. It's not strictly a web technology. That's another kind of service on top of the internet. We'll use these kinds of protocols to format email messages. So if this computer sends a POP3 formatted message to this computer, and this computer knows how to understand POP3 messages, you've got mail. Other questions about web technologies? Okay, I'm going to introduce you to a diagram that you'll be seeing for the rest of your career. The client server diagram. So this is client. This is server. Client is somebody who sends a request. A server is somebody who answers a request. That's it. In a lot of cases, we would say like this is a browser and this is an API. But these terms are technically more general. Don't worry about it too much for right now, but most of the time, especially like in our mod 3 life, we're talking about browsers, we're talking about clients, we're talking about browsers, APIs, and servers. Really, client, somebody who makes a request, server, somebody who answers a request. So these requests, generally speaking, are formatted with HTTP, as are these responses. So we'll call that an HTTP request, an HTTP response. Kinds of things we might send with HTTP. Hey, can I have this file? Kinds of things the server might say. Sure, here's its contents. So when I ask for, hey, computer, this IP address, which conveniently has the URL firebase.com or whatever, can I have your index.html file? Or I guess, put it another way, a different color. Can I get the index.html file? The server goes beep boop, beep boop, beep boop, and goes, yeah, sure, no problem. Here's what was inside of it. And then whatever else. Your browser goes, hey, that's HTML. I know this. And then makes pictures show up on your screen. Ta-da. That's the web. And then in that HTML file, you go, oh, snap, I also need a CSS file. Hey, can I get style.css? And the server goes, yeah, no problem, here you go. And then sends back the contents of that. And your browser goes, neat, I know this. I know what CSS is. And then makes the stuff on your page different colors and stuff. And then it's still chewing through this original HTML document. And it goes, hey, you're asking for like a JavaScript file. You should go look that up. And so you go, cool, can I get the app.js file? And your server goes, well, I happen to have it right here. Here's the contents of it. And then your browser goes, this is JavaScript. I know this. And it starts chewing through your JavaScript line by line by line. And then it goes, ooh, I'm supposed to get a list of the Pokemon. Can I get a list of Pokemon? It's not a file, but if I send you a request that's formatted this way, can you do that? And the server goes, all right, let's see, you're trying to get Pokemon. Awesome. Well, what I'm going to do is I'm going to go look for those in the database. I'm going to get them, I'm going to format them, and I'm going to send it right on back to you as JSON. And then your JavaScript goes, cool, this is JSON, I know this. And then turns it back into JavaScript objects. All right, I've just described 99% of the internet. Works just like that. Works big, works small. Facebook or your fucking Mod 2 project, all of them work that way.
Sounds like just a giant volleyball game.
Yep, that's exactly what it is. It needs to go back and forth too. That's part of the HTTP protocol, is that it's a circle. You can't send a request and then not get a response. Even if like you're adding something to your blog or writing something to the database, your server still needs to say like, okay, cool, it worked. Otherwise, it's a failed request. That's not true of every protocol, but it's true of HTTP.
Is there a limit on how many requests you can put out?
Yep. 6 at a time. But that's just enforced by your browser. That's not like the law. So yeah, if you fire off 50 requests, your browser will do 6 at a time. And as soon as one resolves, it'll queue up the next one. There's a new version of HTTP. It's not even that new anymore. There's a thing called HTTP 2 that works slightly differently, that gets around that with a thing called muxing or multiplexing. Or if like you're asking for 50 different things from the same server, it just weaves all the requests together and weaves together the responses. It's kind of fucked up. But But yeah, not useful for right now. But yeah, there are limits to how many you can do it at the same time.
I have a question, Kyle.
Yep.
So with browsers, we can send out 6. Is there any limit to servers? Because I know the thing called Hug of Death.
Yep.
Server just gets overloaded.
Yeah, this isn't magical. This is just a computer. And so like your computer can get too busy. And so if your computer gets too busy, your computer crashes, whatever thing is happening there, cool, there's nobody to take my HTTP requests anymore. That's the hug of death. One of the neat things about the cloud is since that's abstracted out, it's not necessarily going to a physical computer. You can tell Amazon, I think of this as a computer, but if it gets busy, could you maybe pretend it's a bigger computer? And then they do that, which is pretty cool.
Is that when we like consider what kind of server like we'd be like looking at, like if we're gonna be like horizontally or vertically scaling? Is that like where we would think like when to bring in like cloud services?
Yep. So like horizontal scaling would be like, give me more servers and split the work across them. And then vertical scaling would be like, give me a faster server. But yeah, that's just filling out a form differently and like moving sliders and stuff. So like, hold on, I have a Heroku thing up somewhere. So right now, the Firebase site, it's right here. So it's on the free tier, which is why like if you're the first person to access it in 15 minutes, it takes a second for it to fire up. But if I said, all right, I want to go to the hobby dynos. So I do that. And then now that I've got these hobby dynos, I can, they changed this interface. Maybe I need one of these. Try that. There we go. So the way that I would scale that, oh no, we got crazy busy. You just move the slider over. And so like, it can get pretty expensive, but like this beats the hell out of like ordering new computers off of CDW and waiting for them to ship to you. That's scaling in the cloud. That's pretty cool. Get this shit off my account. Other questions about this HTTP request response cycle?
Yeah, I have a question about the time frame we're talking here. Like just a simple request for an HTML file. Mm-hmm. What's the response time looking like these days for like just on average?
Let's take a look. All of those were HTTP requests, by the way, every single one of these. So if I look at, so this was 36 kilobytes. And we look at the timings of that. There you go. That's all the different steps. TLS is the HTTP handshake thing where we're agreeing on a on like a cipher so that my ISP can't see that what I requested. 32 milliseconds for that entire thing. That's pretty cool. 16 milliseconds to look up the IP address for Google. 133 milliseconds, just cool, everything worked out. We're just waiting for a response now. And then 21 milliseconds to process the response. Fast, man.
Cool, thanks for showing me that.
Yeah. more questions.
So one thing I wanted to parse was sort of the difference between the client and the server. I understand for any given interaction, it's like this party makes the request and sends it to this one.
Yep.
But so the client can request the server, and the server has to send a request to the database, right?
Kind of. Like in that case, your server becomes the client for your database server.
Right. So I was wondering, is there any really defined way to is it just for each interaction they relate?
For each interaction. So something can be a client in one context and a server in another. So if this server is also like requesting something from the Pokemon API, then the Pokemon API is the server, and my server is the client for that. Client is who makes the request, server is the one who answers it.
If I were to try to create like a server from home, what would I do?
If you get a Raspberry Pi, you would set up server software on it so it knows how to listen for those HTTP requests. So like it's what Apache is, for example. And then you would set up your router so that you say, all right, if somebody makes a request to my IP address on port 80, if you could just forward that request right over to whatever IP address my Raspberry Pi is on, and it'll take it from there. And so then it takes the request that came over, it number crunches it, it generates HTML, it reads a file, it does whatever it does. And then it'll send that back to your router. It goes, by the way, whoever was asking for this, can you send this over to them? And then there you go. You're running a custom web server out of your basement.
With as simple as a Raspberry Pi.
Yep.
Wow. Okay.
I'd highly recommend doing it. You will learn a shit ton about networking doing it that way. And you will have your own $35 god-awful server. But yeah, that's
awesome.
a totally worthwhile weekend project.
I'm going to take you up on that.
Other cues.
Feels like to me like security is highly important here. Because you're sending information and like you're talking about users and they're putting in passwords or personal information, so that it's definitely I think that's probably a big piece to all of this as well, right?
Yeah, that's why it was like this year that most of the browsers just outright banned HTTP unsecured.
Huh.
Yeah, if you try to like go to somewhere that doesn't have it's called certificate authority set up for their site, like your browser will go like, even if it's not your credit card information or whatever else, for the love of God, don't go to this site. And that started happening like this last year. Anything else? Cool. So our objective was to describe the HTTP request response cycle. I'm out of time. I got to hop into a meeting. But if anybody wants to DM me your answer to describing the HTTP request response cycle, I will give you a response. I will clarify anything. Also, if you just didn't feel like speaking up and you still have some questions, drop me a line and let's chat. Elsewise, hopefully this was useful.